All right, so 6.1 is fractions, decimals, and percents. Learning target, rewrite fractions, decimals, and percents using different representations. So write the percent as a decimal or the decimal as a percent. Use a model to represent the number. So 74%, what we're going to do is we're just going to do our conversion. So to convert a percent into a decimal, so 74%, we remove the decimal point, we remove the percent symbol, and we move the decimal point twice to the left. So 74% becomes 0.74. That's 74%. So to go the other way, to turn a decimal into a percent, take 0.79 and you move it the decimal place twice, but this time we're going to move it to the right. And then you place a percent symbol at the end. So 79 thousandths becomes 7.9%. For the repeating decimals, so 4.3 repeating, I write out as 4.333333333 continuing forever. And then I move the decimal point twice to the right. If we're moving it a percent, we want the percent sign at the end. So that's how I remember to move it to the right. So if we're turning it into a percent, I move it towards where the percent sign is going to go. So you move it once, twice, right? The percent sign is going to go at the end. I'm moving the decimal point back towards the percent sign. That's how I remember to move it which direction. So this becomes 433.3 repeating percent. So those are turning percents into decimals, decimals into percents. You move the decimal place twice. All right, what about fractions as a decimal and a percent? Okay, so they want them as a decimal and percent. Well, good news, because turning fractions into a decimal is very easy with our friend calculator here. So 1/6, we can just do what the fraction says, and 1/6 is 1 divided by 6. And when I do 1 divided by 6 with a calculator, or just by hand, I get 0.16666666666. So as a decimal, it's 0.16 repeating, just the 6 is repeating. And then as a percent, remember, I'm going to move the decimal place twice to the right towards where I'm going to put the percent. The percent sign goes at the end here. So I'm going to move it twice, once, twice there. So the percent, 1/6, is equal to 16.6 repeating percent. All right, what about 3/8? Well, 3/8, I'm going to do 3 divided by 8. And 3 divided by 8 is 375 thousandths. And as a, so we should write that. So 375 thousandths. And then for a percent, right, the percent's going to go at the end. So you move the decimal place twice towards that percent sign. So percent is 37.5%. Okay, so there we go. Decimals, fractions, and percent. Last one, 14/9. So let's move it just a little bit over. So 14/9, let's do 14 divided by 9. And 14 divided by 9 is 1.55555555555. 1.555555555555555. Da da da. Okay, so as a decimal, 1 and 5/10 repeating, and that should make sense because 14/9 is more than a whole, is more than one whole. So as a percent, right, percent sign's going to go at the end here. So let's move the decimal place twice backwards towards that percent, and we're going to get 155.5 repeating percent. So there we go. There is fractions to decimals and percentages. Turn the fraction into a decimal by dividing, and then decimals to percents by moving the decimal place twice. All right, let's do a word problem. So for School Spirit Day, 11.875% of your class wears orange shirts. 5/8 of your class wears blue shirts. 0.15625 of your class wears white shirts. The rest of your class wears gold shirts. All right, order the portions of your shirts from least to greatest. So let's write all of these out. All right, so I just rewrote the information there. So orange shirts, 11, basically 12%. Blue shirts, 5/8 of the school wears blue shirts. So a lot of them wearing blue shirts. And then white shirts, 0.15625. So to compare portions, I like to make them all percentages. So so this one pretty easy, right? Put the percent sign at the end. Let's move it twice. So white shirts, 15.625%. So basically 16%. Blue shirts, 5/8. Do 5 divided by 8. And 5 divided by 8 is 0.625. And then move the decimal point twice to the right. So once, twice. Oh, that was not good. Goes there. Is, yeah, 62.5%. So way more than the rest. So far it's blue, white, and orange. Oh, least to greatest. Ooh, be careful. So orange, white, and blue. So how many is gold shirts? Well, if you add up all of these percentages, right, and subtract it from 100, we're going to find out how much are the gold shirts. So let's take 100%, that's all the kids, and minus the orange shirts, the blue shirts, and the white shirts. All right, and that's what we're going to get. So if we take 100%, right, that's the whole entire class, and then all the students, and then we take away all of the other people wearing the shirts. So the 11, basically 12%, the 63%, and the 16%. Take that away from 100, and that'll be our gold shirt. So let's find out how many are gold shirt people. Wow. Doing that, it turns out that this here is 90%. So this number here, 90%. So how many people are wearing gold shirts? Gold shirt people are 10%. 10% people are wearing the gold shirts. Okay, so let's do that here. I'll do that in the yellow. So gold shirts, that 10% number. So orange shirts, blue shirts, that white shirts, we'll leave white. Okay, white shirts we'll leave here. So that's the white shirt number. And then orange shirts, let's get an orange color here. All right, and then the problem said, list them from least to greatest. So the smallest percentage is the gold shirts. So it would go gold first, and then orange shirts. So gold, orange, white, and blue. Gold, orange, white, blue. Okay, and that is 6.1, fractions, decimals, and percents. Thank you. Catch you in the next one.